In this video, we're going to be discussing the discriminant. So the discriminant is just part of the quadratic formula. And specifically, the discriminant is the part of the quadratic formula that is underneath the radical. So this b squared minus 4ac, this is the discriminant. And the discriminant is a fairly useful thing. It's used to find the number and types of solutions of a quadratic equation. It won't actually tell us the solutions, but it'll tell us how many they are and whether they're real or complex. So let's take a look at how we're going to do that. So our discriminant can be three things. It can be positive, it can be 0, or it can be negative. So a positive discriminant means that if I do the discriminant b squared minus 4ac, I'm going to get a number that's bigger than 0. A 0 discriminant means that if I find the discriminant, it's equal to 0. And a negative discriminant means that if I do my discriminant, it will be less than 0. And these tell us different things about our solutions. If the discriminant is positive, then the quadratic will have two real solutions. So there'll be two numbers for the solutions, and they'll both be real numbers. If the discriminant is 0, then there will be exactly one real solution to your equation. And if the discriminant is negative, then there will be two solutions, and they will be complex solutions. So let's take a look at what this means for a problem. So example 1 says, for each equation below, determine the number and type of solutions. So I'm going to go through each one of these, and I'm going to find the discriminant, and that'll tell me the number and type of solutions. So here I've got 2x squared plus 3x minus equals negative 3. So my first step is to add 3 on both sides, so that I've got my quadratic in standard form. Then I can go ahead and I now know that this is going to be A, this is B, and this is C. So if I plug those into my discriminant, I get 3 squared minus 4 times 2 times 3. So 3 squared is 9, and 4 times 2 times 3, that's 8 times 3, that's 24. So I've got 9 times 24, that's negative 15. So my discriminant is negative, which means I know that this quadratic has two complex solutions. For this next one, first step, well, this one's already in standard form, so I can just jump right to my discriminant. Okay, I know that my A, there's a 1 here that I'm not writing, that's my A. This negative 5, that's B, and this 3 is C. So if I plug these into the discriminant, I've got negative 5 squared minus 4 times 1 times 3. Negative 5 squared is 25. 4 times 1 is 4 times 3 is 12. So this is 25 minus 12. So I get a discriminant of 13. 13 is a positive number, so I know that this has two real solutions. Finally, for my third one over here, I've got to get this into standard form, and the way I'm going to do it is by subtracting 6x and adding 9 on both sides. So if I do that, on this side, these all cancel out and I've got 0, and on the left-hand side, I end up with x squared minus 6x plus 9. So I've got, once again, a 1 that I don't see here. That's my A. My B is negative 6, and my C is 9. So now I'm going to plug those into the discriminant. Okay, if I do that, I've got negative 6 squared minus 4 times 1 times 9. Negative 6 squared is 36, and 4 times 1 times 9, 4 times 1 is 4, times 9 is 36. So I've got 36 minus 36. So in this one, my discriminant is 0. And because I have a discriminant of 0, I know that I'm going to have one real solution. And I can also kind of think of these as telling me something about my graphs. I'm going to kind of move these down so I can see them. Okay, I can think of these as showing me something about my graphs, in that for my quadratic with two complex solutions, right, if I have no real solutions, if here's my coordinate plane, if it has two complex solutions, it means that when I draw in my parabola, it never touches the x-axis. It has no real solutions. For this one that has two real solutions, when I draw in my coordinate plane, if I draw in my parabola, it has two solutions, two x-intercepts. And for my one with one real solution, well, for that one, I know that if I drew in my parabola, then this one would touch the x-axis exactly one time, and that would be my one solution. So that's what this discriminant does. It tells us how many solutions there are and what type of solutions they are. So I'm going to leave you with this try it problem. It says determine the number and type of solutions, then solve. So you need to use the discriminant to figure out how many solutions this is going to have, and then use either factoring or the quadratic formula to solve.